It's 2005 number 4 and 2003 B number 3. It's the scoring and solutions guide. So let's jump over to the first one here. Okay, this is the 2005 number 4. It says test A, but it doesn't have a test A, test B. There's usually the actual test and then test B. So that's this. If you looked it up, it'd just be 2005 number 4. Okay, so let's look at this. It says some boxes of certain brand cereal include the voucher and a free video inside. The company makes cereal claims that the voucher is found in 20%. There, it's important. Of the boxes. However, based on their experience eating this cereal at home, a group of students believes the proportion of boxes is less than 20%. So this is what we believe to be true. This is the kind of the historical, which I'm going to be using in my ho. This is what I'm going to be using in my ha, because of my alternative hypothesis. That's what I'm trying to show. So then it continues and says this group of students purchased 65 boxes. So this is their sample. And so that's their N. To investigate the company's claim, they found that 11 vouchers, so that's their X, their successes, had a free video in the rentals in the 65 boxes. So then it talks about our conditions. Suppose it's reasonable to assume the 65 boxes by the students are a random sample, so that's good. That's my random sample condition. And based on this sample, is there support? When it says is there support of so students' belief the proportion of boxes is less than here, provide statistical evidence. Guys, that is telling you to run a hypothesis test. And the ha, which I already kind of highlighted what we're looking for, it's always my question. What am I looking for? Because if you think about it, I want to be able to run my test. I want to run a test, and the test is always going to be against what I believe to be true. So let's go ahead and start this. So it wants us to run a hypothesis test, and the first thing I'm going to do is I'm going to define with phantoms. I have P, H, A, and T, O, M, S, and P stands for parameter. And I'm going to define my parameter, and the parameter is P equals, and I'm going to just copy paste exactly what it tells me. And it tells me right here, the proportion of boxes in this brand of breakfast cereal that include a voucher for the video rental. So I'm going to make sure I am specific. So it is the true proportion. True proportion just means that's the proportion actually in my population that I'm studying. So the true proportion of boxes of cereal of a certain brand that include a voucher. And 4, what's the voucher for? A free video rental. Make sure you are specific. Otherwise, College Board will not give you the credit for defining your variable. So next is my hypothesis, and I've already indicated to you that I've got ho, H is going to be P is equal to 0.2, because that's what it's believed to be true, and ha is going to be P is greater than 0.2. Oh, sorry, excuse me, less than 0.2, because that's what it looks like I am questioning. And if you notice, of course, my P hat, which I'll just put on the side, you don't have to put it over here. I'm just saying put it on the side because we have, remember, that's my X over N, and that's going to be 11 over 65. So we're going to bring that in later. Okay, my assumptions and conditions. Now that's my, what I call my RILT, right? And my RILT is, it says a random sample, so I'll just put random sample. You can do this. This is kind of nice if you just kind of go like this. Reasonable to assume, you could say reasonable to assume, and you could just quote that right there. I just write random sample as given, because that's exactly, or you can kind of put a quote and just show that it's made. And then remember, my independence rule is going to be, my independent and 10% is going to be connected to each other. So we have 10 times my 65 is going to be less than all boxes of the cereal. And you can say that they're independent, obviously, that they're going to be independent, that each box is independent. Each observation is assumed independent from the next. So we just don't want them to be connected to each other. And then finally, large, which I did that independent, the 10%, and the large sample, remember, is going to be using my N, because this is a hypothesis test. I need N, P, and Q. And so my N is 65. My P is 0.2. And then I say, well, that's greater than or equal to 10. And then we need to do 65 times 0.8. And that's greater than or equal to 10. So large sample indicates what, of course? Indicates that normality, normal model would be appropriate. And so we now can name the test, and we're going to do a one proportion z-test. T, my test statistic, we're going to go ahead and it's going to be, I'm going to just write it out for you, p hat minus p over square root of pq over n. I'm putting it over here because I don't want you to put it on your test, because sometimes if you mess up the symbols that you get marked off on the AP test. But this is column 1 minus column 2 divided by column 3 on your chart. And so first of all, my p hat is 11 out of 65 minus my p was 0.2. I could go ahead and make 11 out of 65 into a decimal if I wanted to. And so if you wanted to, you could just put that's 0.17. So if you wanted to, you could put 0.17. And that's going to be divided by square root of 0.2, 0.8 over 65. So then what I do next is I put this into my calculator. So I'll just show you. Let's bring this up to my calculator. So I open up a one prop z-test. So the way you do that is menu, stat, test, one prop z-test, and my p is 0.2. This is the PO, that's the p that's in your your null hypothesis, and we had 11 over 65, and we were saying that is less than, so I need to change it to less than. So I hit OK, and then there's all my data right here. So my z is negative 0.62, my p-value is 0.267, so this is going to be negative 0.62. If I drew it out, and I've normalized it already, so I'm just going to go 0 and 1, negative 1, negative 2, negative 3, and that's going to be here. Z is equal to negative 0.62, and shade it. That's the p-value, which I said is 0.267, I believe, which is the O, obtain your p-value. So the p-value is equal to 0.267. M is to make a decision regarding HO. So we're going to say since p-value is equal to 0.267, and that is greater than alpha. I'm going to say, because 0.05, I chose it to be 0.05 because they did not give us an alpha to do. I'm going to fail to reject. And you could either say HO, or you could say that the proportion of boxes of cereal is equal to 20%. So you're saying, hey, I'm not going to reject that. And you would say the state in context is going to be, you're going to state your conclusion with regard to HA now. So we do not have enough evidence for HA. Have enough evidence for HA, which says P is less than 20%. So let's do the scoring. Okay. I'm going to have this score. First of all, do they have P equals? That's a point. Do they have this statement? And I'm going to say right or wrong is the statement detailed. Okay, so that's going to be 2 points there, right, for the P. For the here, do they have HO? Do they have P equals? And do they have 0.2? So that HA, P less than 0.2. So I'm going to say that's 6 points there. For RILT, I'm just going to do 1 for R, 1 for the I and the T, and 1 for the 10% rule. So that's 3 points there. Name, did they name the correct test? That's just 1 point there. Okay, for this one, there's quite a few things. Do they have Z equals? Do they have each? I'm going to do each individual. This here is 1 point here. So, and then the Z score. So 1, 2, 3, 4, 5 there. But then do they have the model? With the model, do they have it labeled? Do they have the Z score? And do they have it shaded? I'm just going to do it in a different color here so we can see. So I've got here as 1, 2, 3, 4, and then 5, 6, 7, 8, 9. 9 points there. And for this one, 1 point that they've got the p-value at some point somewhere, and then make a decision. Did they make a decision? First of all, did they make a decision based on alpha? So is the decision based on an alpha, and is so decisions made to alpha, and is it a correct decision? Was it fail? So that's 2. And then don't worry about doing their wrong or right answer. Just grade it directly, just so it'll be easier for you to grade. And then finally, so we do not have enough evidence, and then you're going to say for what, for how, which is here. So that's 2 points there. So what you can do on the grading is you can put on the notes, wherever they missed, you can say the P and phantoms, they got 2 out of 2, the H and so forth and so on. So that's what I would do on this. I think it's easier. Okay, let's jump over to the next question. And the next question is 2003 and number 3. So for this question, it's actually asking, first of all, it says, is this an experiment or an observational study? So an experiment is when you have a treatment, and an observational study is just when you are actually watching it and you're not doing anything. Well, let's kind of read and see what we're going to be looking at. So we have a study conducted in taking vitamin C reduces occurrence of the flu. The study was conducted amongst 808 students, volunteers who did not take a flu shot. So that's my population. The subjects were randomly assigned. Okay, we've got our random, that's our R, to one of 2 groups, a treatment group who received, and notice it says treatment literally in here. So immediately I can stop and I can say, okay, I can say this was an experiment because there was a treatment. And you need to tell me what the treatment was. So you're going to say there was a treatment imposed. And if you kept reading on, you'd see that the treatment was randomly assigned. Of course, treatment imposed, it was randomly assigned to 2 groups, which we had. The 2 groups were placebo and vitamin C were my 2 groups, right? Okay, so and I'll talk about the scoring here in just here. Basically, I would say a point for saying experiment and a point for saying treatment, and either saying they were randomly assigned to 2 groups, or you could say that they had 2 treatments. That I'm going to make that 1 line, so that would be 3 total points here. All right. And then, so yes, you continue to read on and it gives you the data. And then secondly, it says, based on the study, a health expert claims that there is evidence to suggest. So guys, if it says there is evidence to suggest, basically it's saying the p-value is less than my alpha. So that's what it's saying. There is evidence. To reduce the population of students would volunteer to each study, state the name of the test. So we just have to name it. What type of test would this be? And the null and alternative hypothesis that they would use to support the claim. So this one would be a very easy one. And so I would say the first thing I'm going to do is I would define my variable, and I would have to say P1 equals, so this is for part B, the true proportion of those receiving vitamin C who got the flu. Or you could call it P, and you could put a C there or something for vitamin C. The next one, P2, or you could put P, maybe a P for a placebo or something like that. And I'm just going to do this because it saves a lot of time. Oops, not vitamin C. This is placebo. And these are the people that got the flu. Okay, so that's the first thing I'm going to have to do. The second thing I'm going to do is say, okay, well, HO is going to be P1 equals P2. Or they could say P1 minus P2 is equal to 0. And then ha is going to be P1 is less than P2. Or, of course, they could say P1 minus P2 is less than 0. Now, I want to tell you, if they did not define the variables, but they wrote ho and ha out in words, then that's the same thing, and they will get the points for the variables. You only have to define the variables if you use variables. But if they wrote it out in words, you do not have to do that. Okay, so we had to do the null alternative hypothesis, and the name of the test, this is going to do a two-proportion z-test. And of course, or they could call it a two-sample z-test for proportions. Either way. All right, so the points here. P1 equals, and then the true proportion of vitamin C. P2 equals the true proportion of placebo. I get ho, and I should say P1 is equal to P2. And ha, P1 is less than P2. Of course, if they did this, that's fine. And then that is a two-proportion z-test. So that's the points. Again, if they wrote out these points, if they wrote them out in words, they would get these points, these 4 points. So I got 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I got 9 points for these, 3 points for these, 12 total points for this particular one. And I hope that helped. Thank you so much.